Hey everyone, and welcome to this video on permutations and combinations. So if you are going to attempt an entrance examination which contains quantitative aptitude section, this topic is very important for you. So before moving on to the concept, just remember one thing, that whenever the question states and, we'll have to multiply, and whenever it states or, we'll have to add. So add means multiply, or means add. Let's get started. So permutations. First of all, permutations is always used when the question is asking you to arrange something. So whenever you see the word arrangement, you'll have to use permutation. Now what is permutation? If you have four men and you have four seats, you have to make them seat on four chairs, right? So we'll use the formula of permutation, that is NPR. N is the total number and R is the ones that you have to select. So the formula for NPR is n factorial upon n minus r factorial. So in this case, we have four men and four chairs. So n is also 4 and r is also 4. So we'll have 4 factorial upon 4 minus 4, that is 0 factorial. The answer will be 4 factorial because 0 factorial is 1. Right? So let's move on to a question for your better understanding. So the question is, 5 boys and 4 girls stand in a row for a photograph. First, in how many ways can this be done without any restrictions? So we don't have any restrictions. We have 9 people and 9 places for them. So the answer will be 9p9. That is same as 9 factorial. Second question, find the number of ways if all the boys have to stand together. So what we'll do is we'll make a separate group for boys, and the second place for girl 1, third girl 2, girl 3 and girl 4. So in total, if you see, we have 5 places, 4 for the girls and 1 for all the boys together. So these 5 places can be arranged in 5p5 ways, that is 5 factorial, and the boys itself can be arranged in 5 factorial ways because we have 5 boys. So the answer will be 5 factorial into 5 factorial because we have 5 places, and in the places of boys we have again 5 boys. So 5 factorial into 5 factorial. Now the number of ways if all the boys and all the girls stand together. So now again we'll make a separate group for boys and a separate group for girls. So that means we have 2 places which can be arranged in 2 factorial ways into the boys are 5, so they can be arranged in 5 factorial ways, into we have 4 girls, so they can be arranged in 4 factorial ways. The total answer will be 2 factorial into 5 factorial into 4 factorial. Moving on to next question, the number of ways if no two girls are together. So in this case, what we have to do is we'll separate out the girls with the boys. So we'll write b1, b2, b3, b4, b5, and on the left and on the both sides of b1, b2, b3, b5, we have a blank space where the place can be filled by the girls, right? So the boys are 5 and these 5 boys can be arranged in 5 factorial ways, and we have 1 2 3 4 5 6 blank spaces which have to be filled by 4 girls. So 6 spaces have to filled by 4 girls. N is 6, R is 4. So we have 5 factorial into 6p4, right? So this was all about permutations, and we also have some special cases in permutations which I'll be covering in a specific uh, different video. So now let's move on to combination, right? So when is combination used? Combination is used when we have a question of selection. So whenever you hear or read the word selection, straight away think that we'll be using combination, right? So what is combination? Suppose I have a 14 players and I have to make a team out of them, and the team has to consist of only 11 players. So here I am not arranging anything. I am selecting 11 players out of a given 14 players, right? So the formula for combination is NCR is equals to n factorial upon r factorial into n minus r factorial. So n is also same, r is also same as it was in the formula for permutations. Let's see this with an example. We had 14 players and we had to select 11 players, right? So n is 14 and r is 11. So we'll have 14 factorial upon 11 factorial into 14 minus 11 factorial. That is 14 factorial upon 11 factorial into 3 factorial. Right? You can solve this to get the answer. Now let's see another question for your understanding. So we have a team of 6 members. We have a team of 6 members to be formed out of 5 doctors, 9 lawyers, and 5 engineers. So what's the first question? That is, in how many ways a team can be formed in total? So there's no restriction. So we'll see that we have a total of 19 people, 5 doctors, 5 engineers, and 9 lawyers. So out of 19 people, I have to make a team of 6 members. So it's as simple as that, 19C6, which will be 19 factorial upon 6 factorial into 19 minus 6 factorial. That is 19 factorial upon 6 factorial into 13 factorial. Second question, how many teams can be formed with 2 doctors, 3 lawyers, and 1 engineer? So now here we have a restriction. What we'll do is we have to take 2 doctors only out of 5 doctors. So we are selecting 2 doctors. So it will be 5C2. Now we have 9 lawyers, but we have to select only 3 lawyers. So it is 9C3, and we have 5 engineers, out of which we need only 1 engineer. So we have 5C1. So we'll multiply with these all because we need 2 doctors and 3 lawyers and 1 engineer. So and means multiplication. So 5C2 into 9C3 into 5C1. This will be our answer. Next question is number of teams with exactly 3 lawyers. So now we need exactly 3 lawyers out of 9 lawyers. So out of 9 lawyers, we need 3, so it will be 9C3. Now we are left with 5 doctors and 5 engineers. So in total we have 10 of them, and further we have a team of 6 members, out of which 3 has to be lawyers. So we are left with 3 more members who can be anything, whether it be doctor or engineer. So the answer will be 9C3 into 10C3, because we need 3 lawyers and 3 more people. So 9C3 into 10C3. So thank you so much for watching this video. I hope you get an understanding of what is permutations and combinations. So if you like the video, do not forget to give your reviews in the comment section and subscribe the channel for more videos, because I'll be covering most of the topics for quantitative aptitude. And share it with your friends whom you know are going to attempt an entrance examination. And thank you so much.